Hello developers, let's start developing. Today we're gonna take on the 10th task of the Advent of Code 2022 and finally I'm at home at Skopje, so this should be a more enjoyable experience. I'm not in a random hotel room across Europe and a small part of Asia. But let's see if that helps me in solving the problems. We have to do a cathode ray tube. Actually, I took a look at an input for this task, so I thought it was something about, yeah, it's something about some kind of registers and things, which are usually my favorite kind of tasks, because we need to use a computer to simulate a computer. Mhm. Yeah, we're left stranded by the elves and we need to talk, and yeah, our screen is broken. Clock circuit, yeah, we have a cycle, figuring out single register, okay, that's not too complicated, and we have, yeah, I don't think that this is able to actually do anything. Somehow tell the string what to draw. Yes. Uh-huh. So we have a case like this, the clock goes 0, 1, 2, you get the point. 4, 5, 6, and so on. And here we have, just a sec, the register starts with the value 1. Well, that is unusual for a register. And then we have a no-op, which doesn't change as the register and takes one cycle to do. Yep. And then we have an add x, which takes 2 cycles to complete, which means that, yeah, this is a no-op. This is add 3, and this is add x minus 5, I guess, yeah. And it's not like this because it's like this. And in this cycle we have the value still 1, and in this cycle we have the value 4, and this we have the value 4, and here we have the value minus 1. Okay. Seems like a computer that's not capable of anything. During the 5th cycle, x is still 4. During. After the 5th cycle, the finishes execution and x is minus 1. The signal strength. The cycle number multiplied by the value of the x register during the 20th cycle and every 40th cycle after that. The larger program, yeah, it's a program. During x has value 21. During 'Okay, this was gonna trip me up. During the 20th cycle. So we don't have the situation like this, that the situation is like this. Yeah, because we need the values during, and then we don't have a zero cycle, because we can talk about things that are happened after the zero cycle, meaning before the first cycle gets started, but it doesn't make sense to talk about things during the zero cycle, because there is no such thing as a zero cycle. So we need to simulate this, and 20, 60, 100, 140, 180, 220. and we can basically ignore everything after that. Let's abuse Excel a bit. Actually, let's see if we actually need to program for this. This seems like an easy thing. So this is during the first cycle. This is, let's take the example input. Because that is a known quantity. Yeah. Text color automatic. So during this call, which takes two cycles, the value is 1 and the cycle count is 2. Now the cycle count during it is basically it's less than 2, we can say that. During this it's 16, and the cycle count is less than 4. During this is 5, and the cycle count is less than 6. I'm hoping that I'm making some sort of sense. Yeah, we can do some formulas that will get us this, but to be honest, I think that we might try even some programming. Let's try that. So day 10 txt, and we need to paste this value. Let's have it running constantly. We don't care. Let's just exclude part 2 for the moment so we don't run at that, and we're gonna need to basically read all the lines for it. So once we read all the lines for it, what do? Well, we need to map them using some kind of a but let's complicate the mapping because I would like to extract as much data as possible. And for some reason my computer is running slow when we try to do that. So at the very least I will restart this, but in a separate window so we don't have to look at it unless we want to. Yeah, you can go away as well. So let's model our input because this looks something that will be relatively amenable to modeling because we have two different cases. So we can say a command it can be either an add or a no. And I think they added we will either have more tasks when we have to add more conditions on this and more of everything, or alternatively they just added an X so that it's just the same length with no. I'm gonna call it add, and then we're gonna have an interface that's gonna, this is not a command, we will call this something else. This is an instruction. Yeah. And let's say we're gonna have a type of command, which is gonna be either a add command or a no command. And now we haven't defined those. We can define an add command, which will have an instruction called add, and it will have a value that's a number. And we will have a no-op command, which will have an instruction that's a no-op, and that's all there is. So right now, our type of command will have an instruction that is add or no-op, which is basically an instruction, which turns out we don't really need. And we have sometimes we need a value. So we can go for each line and say if line equals no, return no command. Yay! Kinda good that I kinda like regex, but to be honest, if we parse the regex, we will need to take care of the minus, we will need to take care of everything, and in this case, I can just say line dot substring. Where do we start? We start from the addx space, start from the fifth character, and take everything else, and then we just need to run it through parseInt. And one thing that I've been forgetting is that we always need to have, in JavaScript, it's always smart to have this 10 at the end, so that yes, we actually need decimal parsing. So one thing that we will need to say here to convince TypeScript that we know what we're doing, we're gonna need to change string array to a command array. That's our type. And we get the value here, and then we're gonna return, yes, this. Thank you, Copilot. Let's just run this with a debug type, so to see whether we are parsing our input correctly. Let's just save this. The input that we are using, so we have 9 add methods with some specific numbers, and then we have a no-op method. Let's see if this is getting something done. It's getting an error down. Promise of void. Why did we do this? Because we calculated an input and forgot to return it. And that's why you need to test whatever you wrote, because otherwise, yeah, we would have wondered why nothing is working, and the reason could have been that we are just not returning an input. So we have 15 minus 11, 6 minus 3, 5 minus 1, 8, 13, 4, and then a no-op. Yeah, seems like the parsing of our input is correct. Let's terminate this. The debug mode is off, and we mostly need it to test our input. Seems that our input is okay. So now we want to run the simulation. So basically, let's say we have a register. device. We can have just a single integer here, but this way it's more fancy. We're gonna have the register X. It's gonna have the value of 1. Yes, this is our device that we're gonna do it. So we just not now need to do a for loop across our commands. And our result. This is gonna be our counter, and we're gonna have also our result. And we need our, what else did we need? We need our measuring points. But let's take care of those later because we're gonna need starting with the 20th and then every 40th. Why? Because it said so here. Let's ignore that, and let's have this somehow running somewhere. So this is before the first. So what we need to do? We need to actually implement, and we can say if command dot instruction is add. And you can see that now here TypeScript will help us, because if we try this, it will say this has only two possible values. It's either an add or a no-op. And if it's no-op, then what we need to do, we'll just need to increase the counter by 1. And continue. And of course the counter is not constant because it increases on every iteration. So right now we can add this thing, but this thing basically always evaluates to true, because right now the command instruction is add, so we don't actually need this. But you can see that when we go to the command, we say that this is an add command, and add commands have value. So here we can do that the counter has 2 more, and the result, not the result, the device.x is increased by the command value. Discontinue, we don't want. And let's just say we do something like this. Yeah. Let's see what happens. We should get a wall of text or something like that. We didn't really need to print the result because we're not doing anything with it. So this runs for 237 devices, cycles. Let's change it again. The register is at that much and the result is not important. Yeah, note that this is the after situation. So now let's compare it to this. During the 20th cycle, the register has the value 21, and after the 21st has 20, so we need to take this value. During the 60th cycle, 60, 60, 60, yep, it's somewhere around here. We should be taking this value, Why does it go for 57 to 61? Oh, because we're not counting no-ops. We're not writing anything when there is a no-op. So we should take this value, 19. Yep. And not the value 16. Now see cycle 100. That's 18. 18. Cycle 140. 21. Yep. 21, not 22. Cycle 180. 16. And cycle 220. And this is a trick. It says after cycle 220 is 19, but during cycle 220 it should be 18. So we need to find the during. And we can get this from a formula, but let's do this. These are the interesting points that we want to take care of. Not pop, because this will take the last element, but shift. This will take the first element. So we're just looking at the 20th element. And now the question is, we're running, presumably correctly, we are running our device correctly. So we just need to focus on a single thing. When does we go over the 20th thingy? So this thing doesn't, up till this point, the register still has the old value. So we can just say, if the counter is bigger or equal to the point, which means that we got to the point where the, yeah, when we got to the point, take the previous value. Yeah, and let add this as a debug message. Yeah, this is the during value. And now we just take the next point. So in the point variable, we always have the last interesting thing. This will get to be undefined after 220. But who cares? Let's put in a million. So this is just so after a while point doesn't get undefined, and I really don't want to do undefined comparisons in JavaScript. In most cases it will be correct, but I don't want to do that. So this is a artificial endpoint that will never be, is never supposed to be reached, just so we have some value. And we will wait some cycles, because we can say here, if point is undefined, then do something, stop processing, break. Actually, why not do that? Yeah, that is this with an artificial breakpoint that should never be reached is one way to do it, but we can also say, since we are not interested anymore, if point is equal to undefined, yeah, you can see from the definition, if we have a first element, it will return it. If it doesn't have a first element, it will return undefined. So if we have we reach the undefined, we break because we're done. And then after we read the value, we can increase it. And we are only interested in actually, is it, we will have a problem here if after the some point we only have knobs, 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 knobs. So let's remove this continue and add an. Do we have such a case? If we have such a case, this console log will never appear after some point. Just a second, seems that this debugger is still connected. Disconnect, disconnect. Yeah. Oh, no, I don't want to terminate it. I want to restart it, but I think I broke it now. Anyway, the result shouldn't have been this. The result should have been point times the device X, and then we should have returned the result. Let's start it once again. So we're doing all of that magic to basically catch the doing part of the situation and not focus on the after, because after is easy. During is a bit more complicated. We have our results, and we have our results for 20 during cycle 21, 2061, 103. Yes, these are the cycles when we actually do the measuring. And we have those values, and the result is 13,140, which, if I'm not wrong, is the one that was mentioned here. So let's take the real input. And let's see if we have exactly the case that I was talking about. Because we do have a few knobs at the end. It's possible that those knobs are the ones that are triggering 220. Nope. Result part 1 is 14,160. Let's see if that is the correct answer that we're supposed to get. Yep, one gold star closer. And let's try our luck to our part 2. Controls the horizontal position of a sprite. Okay, the sprite is 3 pixels wide and X-ray says the horizontal position of the middle of that sprite. So 3 pixels and we're setting the middle. One and the other 2 pixels are just going along. Okay, you count the pixels on the CRT, 40 wide and 6 high. Single pixel during this cycle. Yes, so in the first 240 cycles, we will draw the screen. What? You should be able to know whether the sprite is visible the instant each pixel is drawn. Sprite is positioned such that one of its 3 pixels is the pixel currently being drawn. The screen produces a lit pixel, otherwise the screen leaves the pixel dark. So in each loop of 240 cycles, we have an X, and if that X is part of the pixel, then it's part of the sprite. Yeah, we're setting a sprite. So for example, when we're drawing on the, let's say, 17th cycle, where the device will draw this thing. If there is a sprite here, which means if the position of the register is 16, 17, or 18, then we will draw a lit pixel. If it's not, we draw an unlit pixel. That's all there is. So, larger example above. So, at the very first, at the start cycle, yeah, let's take a look at this. So we have add x15. Let's go here. So we have add x15, and then we have this is add x15, and then we have add x minus 11. So it's 1, 1, 15, 15, 4, 4. So correspondingly, our sprite is at a position x 1, 2, because we don't have a zeroed one, I guess. Leftmost pixel in each row is in position 0. So our sprite is in position 0, 1, 2. Our sprite is in position 0, 1, 2. Our sprite is in position 14, 15, 16. 14, 15, 16. Our sprite is in position 3, 4, 5. 3, 4, 5. I think the third one was also an add instruction. Add x6. Yeah, let's go over the description once more. Single pixel during each cycle. During. So, during cycle 1, the value is 1. So, we are painting a lit pixel. Yeah, let's lose some other colors. So, this will be yellow. During a cycle, why we are painting the lit pixel? Because we are pasting we are illuminating, so to say, pixel 0 of the first row, and since this is 0 is included here, we should be able to draw it. So now we are doing on pixel 1. So this is pixel 0, this is pixel 1. Yeah, let's not do this here. So we have pixels 0, 1, 2, 3, 4, 5, 6, so to say. Let's say. So when we are painting cycle 1, we are painting pixel 0. When we are pasting pixel 0, we are looking at whether the sprite is at pixel 0. Yes, it is. Yellow. Next, we're painting pixel 1. Is the sprite there? Yep. Painting pixel 2. Is the sprite there? Nope. Is the sprite there? Nope. 4. Is the sprite there? Yep, it is. So again, once more, we are doing something and we are doing something. So we will get some image like this, I guess, if I understand it correctly. Start cycle 1. Yep. During cycle 2, third one is yes. Until here, our analysis is correct. Hmm. Oh, these are usually fun. We need to draw something. Yeah. Right now, I will remove this console line because we don't need it anymore. But I will kinda reuse some of this code. And result is a matrix that's gonna be have how many lines? It's gonna have 6 lines. It was 6, right? Yes, and each of the lines fill it with 0 and then map each line to an array of 40, which we're gonna fill with dots. We're gonna say print matrix on this. We don't need this. We don't need the points. We're gonna need the counter because counter is kinda important, but we don't need none of these. We don't need to return the result because the result right now is something else that's not a number. So we're gonna be returning a 0, but we're gonna be displaying something where we can read it. To have a fancy thing about if you want to do something fancy with this, you can always add some kind of an OCR module that will basically read the letters for you, but we will get some kind of an image that we as humans can do the OCR ourselves and have it running. So let's see if this does anything. If I'm correct and my print matrix method is working as expected, means that I should get a dot matrix display. And in this case, it's gonna be a literal dot matrix. Yep. Actually, for better visibility, I'm gonna just fill it with spaces. Let's have the dots, and at the end we will change them to spaces. And we will just move this here. So now we need a sprite position. Yeah, we can determine the sprite position whether the current is at least at most one away from the register. So what we need is, yeah, the counter determines the thing that we are drawing, and that means if the counter is 1, we are at row 0, column 0. If the counter is 10, column 9. So if the counter is 40, we are 039, and the counter is 41, we are at 1, 0. So and of course, if it's 82, we are 2, 1, and so on. And at the very last, I think we will have 240-ish thingies. 240 exactly. This is gonna be 5 and 39. So let's see a formula that will do this. So this is obviously, we take this and divide it by 40. And oh, I have no idea how this was supposed to work. This doesn't really work. But what happens if we take 1 from this and divide that? Then we get the correct numbers. And let's just say if this equals to this. And let's have another set of those only for the other things. That equals that. Yep, empty equals 0. But that's not always correct. So we will have another formula which will say what is the remainder of this minus 1 divided by 40. That's 0, that's 9, that's 39, that's 0, that's 1, that's 39. Seems that we are about correct. So we're gonna need to take the cycle number, subtract 1, and then use that. And this time I'm gonna do it like this. Totally not. So or I can do something else. I can say that I have values which are gonna be the register values, and that's gonna be array of 240 items filled with zeros. And instead of doing this, I will do this. Counter is at this kind of trips me up. I'm gonna rename it cycle here because previously it was just a counter and now it's a cycle. And this is the indication of which cycle we are on. No, this is the indication of which cycle we have finished. So once we start executing command, we are during the next cycle. So at the very beginning of this, I will just increase the cycle by 1. So we are saying we are during the cycle that the command is executing on. So if we have an instruction, actually we don't want it, don't need that, because the other thing is that our results are, no, we're gonna need that, and we'll only use this thing so that we will have values from 1 to 240, because as you can see we have a bit of a mismatch. The cycles are counted from 1, but the grid pattern is counted from 0. So for grid pattern 0, 0, we need to have cycle 1. That is when the -1 in our calculations, in the Excel calculations, got in. So during that cycle, what is the value? So if we have a no-op, during that cycle, the value is not that. It's actually exactly that, because we're just copying it. Do we need this at all? We don't, because we can always take the last one, and we can just say that values of 0 that we're not going to use for anything is 1. Yes, so if we have a no-op, then the value of the current cycle is the value of the previous cycle. And this is always set, because cycle will be 1, cycle of 0 is set, and that's what we have. And here we will increase the cycle by 2, and the cycle value will be that, and the values of cycle -1 is exactly cycle -2. So actually I will change this. So we're setting two values. We're not simulating each one by one, we're just setting the values, and let's just see what the values are. Don't need to print the result yet. So we're going to do this in 2 steps. We're just going to calculate all the values, and then we're going to run another check through our values to see whether a specific pixel should be lit or not. We could have done that in the same cycle, but since once it's going through the commands and the other one is going through everything else, then we could have a problem. Just a second to verify whether we are running with the example input or with the big input. No, we're running with the big input. Let's change it to the example input. And to be honest, this is what we're supposed to get with the example input. Oh, it's a nice pattern. 2, 2, 2, 3, 3, 3, 3, 4, 4, 4, 5, 5, 5, 6, 6, 6, 7, 7. So it's quite impossible to get exactly that in a random way. Let's just restart it with the test input, and we should see the first 3 should be ones, and then we should get something else. Yeah, so we have 1, 1, 16, 16. Let's see if that is what we want. Oh, just a second. 1 plus 15 is not 15. And this is 5, 5. So, yeah, I think that we have an error here. This value is not important. We're not going to use this value. This is the value, the zeroth cycle value, the starting value. So this is the first cycle value, the second cycle value. But the second cycle value is supposed to be 16. What happens here? Let's try to analyze it. We are saying add 15. This is the final value and not the running value. Let's add the device. Then we don't need this. Let's have it in the case the first thing is a no, but actually I don't want that. I'm gonna say that this is device.x and this is device.x. No, I'm gonna, this is also device, so that we are setting 2 with the device.x, and then and only then we are increasing the device.x value. So we are using that as a helper value. During the execution of the add command, which I keep forgetting. I said it something like 70 times, but for me, it's natural that you don't do something during a register update, you're doing it after the register is already updated. And that's the trick in this question that will trip up a lot of people. Yeah, to be honest, the task is totally clear. It always says during when it means to say during. So we are starting with 0, and then we have 11, 11, 6, 1, 1, 16, 16, 5, 5, and so on and so forth. Yeah, this is 0 because we don't need it or want it, and so on. Okay, that means that if this thing is correct, after it's done, we have the values. So now we just need to run through the values. And now we have an index. We don't need to start from 1. We can start from 0. We need to start from 1. The row is, we said it's gonna be this, somebody hurt me, and the column is gonna be this. I have no idea how Copilot got this unless there are already a lot of other solutions for this on GitHub, so it basically cheated. But that's what I wanted to write. So that's the row, that's the column, and now let's see if yes, this. No, this is totally not what I want. So what I want to say, if the pixel is where it's supposed to be, and we are determining that right now we need to determine the sprite position. Yeah, sprite position is values of I. And we need to detect whether the column, which is between 0 and 40, is in that sprite position. So we need to see whether the column minus values of I is less than or equal to 1. That's not result, that's character. So if the difference is less than or equal to 1, then we print out a dash, otherwise we print out a space, let's say. And we're setting this to the character. And let's just print the matrix. This will give us something. Hopefully it won't give us a total mess. If it gives us a total mess, we're back to the thinking part. Cannot set properties of undefined. Yay. Setting null. What do you mean we're setting null? 0. Result is an array of string. We have a row that's should be between 1 and 6. We have a column that should be 0 and 39. Let's see what happens. Yeah, for some reason my computer is acting weird. Let's restart it. And I think I know what the issue is. I just thought of it. You remember what we did in the Excel? No, of course you don't. But we had an error here, so we had to remove 1 from the index. So we're starting from the first value, and if I'm correct, right now we are at position 0, 1. Yeah, so we're gonna start, we're not starting from 0, 0, we're starting from 0, 1, which means that we're gonna end on 6, 0, and we're gonna yeah, we're gonna try to set the zeroth element of the 7th row of our array that has 6 rows, and it's gonna say cannot set properties of undefined because the 7th row of a 6 row array is, well, undefined. And let's rename this index. Yeah, looks much better now, and see if this does something. Let's run it in debug mode. It's gonna be a bit slow. It's extremely slow. You can see the console typing out characters. It's so slow that I'm gonna kill it and rerun it in the console. And let's just add the dots so that we can see what we get. It's starting. It's running. And we didn't get anything even approaching what we were supposed to get. Okay, that means that we have an error somewhere. Let's try it on and debug. Since this is going slow, I'm gonna spare you some of the debugging experience. Yeah, I got up to here. I added some watch things. So we're on row 0, column 0, and the index is 1. And now I see that I totally forgot that this is supposed to be, this difference needs to be 0, 1, or minus 1, which means that we are missing a thing like this here. The absolute difference needs to be less than or equal to 1, which means that the absolute difference can be 1, minus 1, or 0. Because otherwise we're gonna get something like this. So we got way more dots than we were supposed to, because a lot of the dots were negative. They had a negative difference, and each time there's a negative difference that's less than 1. So let's disconnect this, kill this, and see what we get here. We got something else. No, we actually got the exact same thing. Let's run it once more. Maybe we didn't press save. Of course we didn't press save here. So yeah, let's restart it. That's one of the problems with running JavaScript, that you need to save it. And that's why you can say always see developers saving kind of maniacally. Two 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 three 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 four 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 five 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 six 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 seven seven seven. Everything looks beautiful. Let's just change the input. Yeah, this is the input that we have. Let's just have the input that's for the actual task, and let's restart this. Whoa, we got some letters, and now I will change it once more so that we can see it better maybe. And we'll get our password. RGE It can very easily be seen. It's RGE I'm quite confident that this is gonna be the right answer because it's quite impossible from all of that thingamajig to get some letters and then to have them be the wrong letters. So it's quite possible that you make an error typing it in, but it's quite impossible to get the answer wrong. So RG, RP, EFC is the correct answer. We are one gold star closer to our star fruits. We have solved the problem 10. We still haven't solved the problem 7, but that's on me. I said I'm gonna do it today, but it's the quarterfinals. So it's gonna be done tomorrow when we have no football to watch. So I promise you tomorrow the solutions to task 7 and 11. So tomorrow is gonna be the 7-11 day. Bye for now and see you tomorrow.